Alright, so it's been driving me nuts actually because my clarity, my mental. Oh, come on, rotate, camera, rotate. My mental clarity over the last, 2-3 weeks has been a bit fuzzy and constrained. And yeah, well, last night I went to bed, and before I fell asleep, I was trying to create the situation in my mind's eye and to better explain this three rotor system and the reason why I'll need to add an extra third rotor. So I am going to try and explain it, and this is the important part about how it works. And it was very hard to work it all out in my head because there's so many things going on with it. Okay, so I'm going to try and simplify the drawing. I'm not going to draw the whole rotor and everything because everything gets messy. So what I'm going to do is I'm going to start off with a coil. So we have our coil, right? So we have our coil, which is our big canopy coil, which is wound around the canopy. Now, when the coil is energized, so the rotor, two of the rotors that is, will be, so these are the edge view, right? Two of the rotors, edge view, will be sending a south, let's just use south because I want to keep it simple and without complicating, because obviously it's an alternating field, but so it's actually alternating between south and north. It's spinning, obviously it's spinning, so but I'm going to stick with south to simplify this. And so we have two rotors that are actuating, energizing the coil with a south field. Now, what is the equal opposite reaction of the coil in relation to the magnets? The equal opposite reaction is obviously north, isn't it? Because when you're actually energizing a field, it's like batteries in series. So the equal opposite reaction would be north as it's leaving. So as the rotors are leaving the coil, we would see drag because this would be north and it would be pulling on the south field magnets. Okay, so the coil is energized, but it's not actually conducting anything. There's no reverse field as yet because there's no load on it. So our third rotor is our anti-drag system. As I explained, the anti-drag system uses the magnet arrays, like in a magnet motor. Let's just show you that. And these magnets are orientated in series so that we have one pole at one end and another pole at the other end. I'm trying to keep this as simple as possible so you can understand and follow what I'm talking about. Right. So the equal opposite reaction of the coil when there's a load on this, so let's put a load on the coil. Right, so we have our load on the coil. Now at that moment when we apply a load to the coil, the whole coil is basically in a state of electromagnetic attraction to the south poles because there's drag there. So how do we overcome the drag situation when it's leaving? When the rotors are leaving, what we have to do is we have to insert our magnet array, which is what I just showed you, that pink thing, which is a series of magnets. So instead of having a particular pole, which we don't have, what we have is a series of magnets which are alternating. And so the coil normally will be attracted to the south and it will create reluctance on the rotational effect so that it will try to slow it down. So what we have to do is we have to reverse that so that we have acceleration instead of reluctance. And the way to do that is, well, because it's attracted to south, what we do is we place a north magnet first in the series. Right, let me just bring this segment back into view. So the first field that we want the coil to be interacting with is north, and then it wants to chase over to the south, then the north, and the south, and the north. And ultimately it'll be chasing after its own tail, because it'll be looking to grab onto south, which is over here. But this coil, these magnets, sorry, don't generate power because of the way the field is tightly wrapped. So if I get my magnetic pen, what we actually have is, oh come on, stupid thing. When we back out, what we have is an alternating field as it's chasing along. So we have a strong field at that end, strong field at that end, but it's going to chase along to get to the other end, right? So the coil will be saying, oh, I don't want this field, I want to be attracted to the south. So let's say the first one is north at this end, and then it goes to south. Sorry, I'm writing really small. And then it goes to north, and then it goes to south, so on. So, sorry, my camera's not pointing very well. Sorry about that. So what we have is, at the moment of the drag being in effect, the coil is going to ride along that bubble of magnetic fields, and it's going to create acceleration instead of drag. That's the idea behind my third rotor system. The third rotor is to counteract or offset the drag which is imposed by the other two rotors. And we need those two rotors to generate the power, because otherwise we won't have voltage and current output sufficient, because the greater the amount of power generated by these two magnets on the coil will induce the greater amount of counter field on the magnet array. So the more power is coming from these two magnets, the more induced energy is in the coil, and the more that coil is induced, the greater effect it will have on the magnet array, right? Do you follow? And if it doesn't work, then you'd have to flip these poles all the way around. If it's going if it's spinning anti-clockwise, for example, instead of clockwise, you know what I mean. So if you're spinning it in the wrong direction, it doesn't work. Then you rotate it and spin it the other direction to basically determine if you've got it running in the right direction, because this coil will permanently be chasing after. So if this end is north, because there is an end and a beginning, so if this end is ultimately north and this end is ultimately south, but that field, when it gets to this point at this end, we have to collapse that field, we have to reduce it, which is why we step the magnets back on this array. We need to basically fold the field back on itself when it gets to the end. So anyway, I'm printing a new rotor in 3 pieces like I did originally with the other one. This is how I made the original rotor. I've got 2 sections done already. I accidentally over melted one of them actually. So there's 2 sections which I've got to join together. Oops! Ah! Oh, dropping it on the floor. Right, so these sections will be joined together. Can't do it in one hand. Ah! Hang on. Just a minute. It's difficult to... Hang on a sec. Right. So, yeah. Camera just flipped. So I've got another... I'm printing the 3rd section right now. It's on the print bed right now. And I acetone treated it. I accidentally melted this one a bit. You can see it's still a bit melted down there. Too much acetone on it. But it's going to be fine. It's on the inside. It's not on the outside perimeter. So I'm going to join these together when I've got all the pieces. And I've got to... Well, it won't be so difficult to get this parallel. It won't be difficult because it's going to be rested up against the other 2 rotors which are already on the already on my thing, and I've also got to print longer, these things. These have got to be an extra width longer, as in the width of this rotor here. They've got to be longer to accommodate the extra rotor that's going to go in there. And the rest of it basically is, I can still use the rest of it obviously. It just means that I'm going to step it out a bit. And I decided not to wind that other coil I was going to wind, because I thought, well, I'm going to run out of copper if I keep doing this. Why don't I just go with the 3 rotor system, get the 3 rotor system done, print another canopy, because the canopy itself doesn't use a lot of plastic, but the rotors do quite a bit. So the rotors take about, what, I don't know, 5 hours to print or something. Each segment is about 3 hours, 4 hours. So anyway, it's quite a long time. So I decided I'm not going to use the rest of my copper wire, which is there, because I haven't got a lot left. And I'm thinking, well, if I wind that coil now for that canopy I've just made, I'm going to end up running out of wire, because these bigger canopies are going to use much more wire. So I decided, nah, let's just jump ahead. Do the 3 rotor system, because the coupling will be much more efficient. It will be much more efficient than trying to harvest the anti-drag system on the side. So instead of trying to couple to the side magnets on here, which is very inefficient, because we've only got a very small window there, whereas if we have a full rotor width, we have a much greater amount of anti-drags on the system, you see. So I just thought, well, this is stupid. Why the hell am I doing it like that, when I can just make another rotor that's dedicated to anti-drag? And that's why I'm doing it that way. So anyway, I worked it out last night in my head. I spent ages thinking about it, and I was thinking about the approaching field, the exiting field, and I was trying to come up with the right way of doing this. And I come to the conclusion that because of the way these magnets, these magnets work, when you have the magnet on the front, it's going to chase anywhere from one end to the other, which you see it chases. So it will keep chasing its own tail basically. So it will ultimately want to go all the way to that end, you see. And by the time it gets to this end, the coil, right, will no longer be energized. So if anything, it'll be energized. Well, it won't be energized. The capacitor that's being charged up for that cycle on the coil will already be fully charged, and so there won't really be any drag up this end, because by that time the field collapses on itself anyway. So I just thought I'd give you a better explanation on it, because I was trying to work it all out myself, and it's hard for anybody else to understand what I'm doing. So I was trying to explain it simply, and this is the simplest way I can explain it. So anyway, thanks for watching, and we'll keep you updated, and hopefully in a few days I can get, well, I've got to let the rotor, that lot's got to dry out, and I've got to join it together, and then I've got to mount it on there. I've got to print the feet that hold everything together, you know, them legs that go on there. I've got to print them 3 legs as well. So yeah, a few days and we should be able to start. And then I've got to print the bigger canopy as well. So yeah, it's probably going to be next week, actually, thinking about it. Yeah, it's probably going to be about next week, because I've got to do a lot yet, and winding that bigger coil as well. So see you later.